Hi and welcome to a new video tutorial in which we will build a ChatGPT CLI application with NodeJS and TypeScript optionally. If you want to know what's happening inside the video, you can check the outline for different chapters. Also, all the presented code is available on a GitHub repo, link in the description. And in order to follow this video tutorial, you will need an OpenAI API key and Node.js installed. This being said, let's get started. Let's first do some basic setup for our new chat app, and to keep things organized, I will create another folder on my computer. I will call this chat app, and I will cd into this folder and initialize an npm project right here first of all. So we have a package.json file. Let's create a src folder. All right, we have the src folders. What else do we need? We need some dependencies. First of all, since we are using TypeScript, we need TypeScript and TS Node. So I'll call npm install as a dev dependency TypeScript, TS Node, and the types for node at types/node. These three dependencies. All right, and the other dependencies that we want are the OpenAI and the tick token package to measure the length of our prompts. So here I'll say npm install OpenAI and tick token. Careful for typos as always. Just as we did before, we need an environment variables file, .env file, which will hold our OpenAPI key. Since I'm lazy, I will copy it from another package. And also we need a git ignore file, so our source control isn't overwhelmed. And the git ignore contains the .env file and the node modules. We are almost done. We need to create a npm script to start our project. Let's create it. So inside the source folder, I will create yet another folder. I will call this basic chat because later we will do a functions chat, which is more advanced. And inside this basic chat, I will create an index.ts file. And right here, let's first of all only print the API key to the console to see if it is loading or not. And I'm printing this to the console, but as you can see, VS Code is telling me that it can't find the types for this process, even if we installed the types for Node. The reason for this is that is because we don't have a tsconfig file. I will simply steal the one from the other project because I'm lazy, and let's get through it once again to see what it gets. The target is ES 2022, the module is common.js, the root directory is src, the out directory is dist. Even if we won't generate even no JavaScript files, we will directly execute TypeScript with TS Node. We will use explicit strict mode, we will use ES module interop, and I like to use unknown in catch variables. I want to set this to false because I want them to be instance of error. All right. Let's now see the final step is to build a script which will execute our code. And I like to call this start because it is a built-in Node.js script. And usually, since we are using TS Node, again, I can directly execute this with TS Node, but TS Node still doesn't know to automatically load environment variables. This is the reason I will first use Node and then execute TS Node with -r. So here I'll say node run ts node register, and then I can specify the environment file is .env, and then the path to our project. So this is src/basic-chat/index.ts. Save this and let's see if this approach is working. So I will call npm start. And yes, our setup is nicely done. We have now a file which correctly loads our OpenAI API key. Let's proceed into the next lecture and start our implementation. Let's start to build the basic chat application. So I will remove this, and what we need, first of all, we need an import from OpenAI. So here I'll say import OpenAI from OpenAI. We have it. We now need an OpenAI client. const OpenAI is new OpenAI. Like this. Alright, and we want to have a process in which we will have a continuous, let's say, dialogue with the system. So we need a listener to the process standard in. This is very simple because we will access an object which comes from the internals of Node.js, the process object. Then we can call the std_in, and we want to add a listener to this standard process. So I won't use any external libraries. When things are simple, I really don't like to use any other libraries. Maybe there are Node.js libraries which will let me do this in one less line. I like to use what we already have. So when we have a new data object or data event right here, we can call an async function, which will receive an input, and then we can have the implementation of this function right here. And now we can take the user input. So here I'll say const user input, and is our input to string, and then we should simply trim this. All right, we now have our user input. We are now ready to call the OpenAI API. So here I will say const response is await our OpenAI chat completions. We will create, and what we will create. First of all, the model is the ChatGPT 3.5 Turbo, and we need some messages. First of all, let's add a system message. So, no, this is an array. Let's add a system message. So the type of the role of this initial message is system, and here I will call this content is you are a helpful chatbot. And now let's add another message which will contain our dialogue. So here I will add a new message. The role this time will be user because this will be provided by us, and the content will be our user input. And now we have a response. Let's print it to the console. So here I will say console log, and we have the response choices 0 because we will only get one message, and then the message, and then the content. Simple as this. Let's see if this initial implementation is working. So npm start, and here I can say how are you today, and I'm getting a response from our assistant. Let's see it better. For example, I can ask who was Albert Einstein, and it will respond me to this question. And I'm getting a response right here. That's great. The only problem with this initial implementation is that we don't have a context to our prompts. If now I will add tell me more about him, it will tell me, hey, I don't know what you're talking about. I don't have specific information, or I don't have any context. How would you like me to know what you're referring to? Even if we just got another message in which we were talking specifically about Albert Einstein. Let's implement this context or history functionality of our program in the next lecture. In the previous lecture, we implemented our basic chat application. It's working fine, but the problem with it is that it doesn't have a context. Well, the solution is fairly simple. In order for us to add context to our dialogue with OpenAI, so this is what we will implement inside this lecture. Let's get started, and the key to having this context or message history is this messages entry inside our chat completions create request. Well, if I will hover over this, you will see that this is a list of messages comprising the conversation so far. So all we need to do is to simply on each request that we make to OpenAI to also add a new entry in this messages entry. This is what we will do inside this lecture. So first of all, we need to have the content of these messages, this one right here, to be added at a another level, let's say. So I will save this upstairs. I will say right here, this is the context, let's call it. So const context. And this is, first of all, a simple array in which we will add our system role. And since we are using TypeScript, this is an optional step, but I really prefer it. Let's add also the type. So the type for these messages is an array of OpenAI chat completion message param. I can simply copy this type right here and add it to this context, you know, because we are using TypeScript, and why not? And remember, we need first of all the system prompt, because this will always be kept. So I will add the system prompt right here. This is the one. The role is system, and I'm telling you you are helpful chatbot. You know, we can add all kinds of customizations as we like right here. So we have the context saved upstairs. Now we need to add each request to the context and also each response to the context. And we can better do this if we will save this request to an outer function. So I will save this to an outer function. I will call this function create chat completion. So here I'll say async function. I will call this create chat completion, and I will move this response inside the chat completion. So right here, I will remove this inside this. And for the messages right here, we will now have the upstairs context. This is the one. And we are receiving the responses. So here I'll say const response message, and let's get the message from the response. This is the one. All right. Now we have the response message. We now need to add it to our history. So here I'll say context push a new response message, let's say, in which we need a role, and the role, since this is a response, the role is assistant, and the content is our response message content. So we are now pushing to our context our response, and now let's log it. So now all our requests will work based on our context. Everything will work based on our context, and this context will contain both the response and let's say the request messages, if we could say that. All right, and now all we need to do inside our function where we are putting our input right here, we can simply have a history push, history, so not history, context. The role this time should be user, because this is a message from the user, and also the content is our user input. And now we can simply await our create chat completion. And basically, I think we are done. Let's test this implementation. I will say right here, npm start. And I will say, I will ask a question about a personality. All right, there's a problem with the way I'm printing this. All right, let's stop this. Yes, I'm not printing the content right here. Yes, we should directly print the content. One more time. Let's see if we now will have a content. All right, we have a response, and I will say right here, tell me more about him. So now I received more information about him. Let's try something else. I will say right here, I will ask it how is 1 + 1 is 2, and I will say right here, and 3 more is 5, and let's say maybe times 2. So it has the whole context of our dialogue. Well, that's great, but we still have one problem which we need to solve. The problem that as we have a cool dialogue right here, every time we are getting a new response, in particular longer responses, we are resending the whole context back to OpenAI. Well, that's not a problem, but as the context will grow bigger and bigger and bigger, we will have more and more bigger requests, so we will have more tokens inside our request, and at some point we will simply lose money if we will have long requests, even if we don't care only about the last 2 or 3 or maybe 10 messages. Let's see a way in which we can, let's say, delete older messages over a certain threshold of tokens. Let's see how we can delete older messages from the context in the next lecture. Let's now talk about the OpenAI request context. So in the last lectures, we implemented a context for our application. This means that we send the whole context on each request to OpenAI, so it knows what we talked about in a few conversations back. That's great if we want to have a more meaningful conversation. But what will happen when we will simply add newer messages to the queues, especially longer messages? So if I will ask ChatGPT through the OpenAI API, hey, write me a long essay, it will give us that. But what we will do next, we will send that essay back as a context, and then we will ask again. Well, for a few messages that shouldn't be a problem, but as the conversation will go on and go on, the context will get really big, and our objective would be to keep this context low. One reason for this is for us to save tokens, because we will be billed by the tokens from OpenAI, so we don't want our bills to explode. And the other reason is that we don't want to exceed the token threshold for different models. These thresholds are different. For example, for GPT 3.5 Turbo, the simple one, current threshold is 4,000 tokens. For the more newer model, the current threshold is 16,000 tokens. Well, the idea is that we need a limit for this messages queue. This is what we will implement inside this lecture. So let me switch to the IDE. So we have our simple implementation, our chat completion implementation. What we want, first of all, we want a token limit. So I will save a new constant upstairs, and I will call this token limit, and I will give it a lower limit for us to be easier for us to test. And we will also need a way to count the tokens from our request. For this, I will import the encoding for model function from the TikToken package. You know, this package helps us to count tokens, and I will create a new encoder object. This is the one. I'm creating an encoder object for our GPT 3.5 Turbo, but as a side note, most models have the same way of encoding, you know, so this is not so important, just as a side note. So now we have a way for us to count our tokens. Well, the change will be when we are creating a chat completion. So where we are pushing our message right here, then we need to know exactly how big our queue is. And we already get this information from the response. So right here, if I will put an if check, and here we are getting a response, and the response contains a usage entry. As you can see, this is a optional object right here, so it can come or it can be undefined. So first of all, I will check if this object exists, and if this exists, I will say response usage, and then we have the entry total tokens, and if those total tokens are bigger than our max tokens, then we need to do something right here. So I will implement a function. Let's call this delete older messages. Like this. This should be the function. Let me implement it downstairs. So here I will call this function. Alright, and we need an implementation. And the first thing that we need to count on each request is how big our request is, or how big our context is right here. This is our context. We need to count every time we make a chat completions create request. We need to count our context. This is what we will do right here. So first of all, we will want to delete. So this is a iterative operation, let's say. So here I will say let context length, and we need a way to calculate this context length. So I will save this to an external function, and I will call this function get context length. This will be our function, and because it is a more complex function due to the types inside the request, I will pause the video, implement it, and then explain it. Alright, and this is our function for getting the context length. So the context takes our context, and for each message inside the context, the content of the message can be either string or chat completion content part array or null or undefined. But let's say that it is string or chat completion content part array. The thing with TypeScript is that it won't let us leave no stone unturned, let's say. So it will make us to think of every outcomes inside our implementations. This is what you can like but also hate about TypeScript. So if the content is strings, then we will simply add it to the length of our context length. That's it. If this is an array of, this chat completion content part, then for each part, again, we will add it to the total length of the context. Then we can simply return back the length. Now we have the length, and then we can start an iterative process. Again, this is a longer implementation, so I will pause the video. And this is our implementation. This is an iteration. It is containing a while and also a for loop, so it is a little complex. It took a while to write it, so this is the reason I paused the video. So we have the context length, and while this context length is bigger than our limit, we can start to iterate through our context, and then we can delete messages. I'm using an old for loop starting from 0 because I want to make sure that I start from the older messages. For the for of loops, you can't be sure about their starting point. So we are getting the message. We don't want to delete system messages, so I'm making a check for the role. But if there are no system messages, we can simply remove this from context with the splice method. Then we are calculating again the context length, and basically at this point we can break the loop. Let's see this if this is working, and I will start this in debug mode. You can, if you want to test it, you can simply start it just as it is. In the last lecture I implemented a debugger, so why not use it? So I will put a breakpoint right here, and I will start this in debug view. Remove this, I only want a breakpoint right here. So our program started, and I will say it. I told it to tell me about the first Punic War in 200 words. Alright, and I got a nice response. That's great. I will tell it to tell me about the second Punic War now. Lately I'm into ancient history. Alright, and already our breakpoint is hit. As you can see here, I'm getting a request to delete the older messages. If we look at the context, we can see the context right now. You can see that we are starting with the system, and then with the user role, then the response, and then again the response. Let's see how this is working. So we are iterating through the system. We should get to the first role, which should be system, so we won't get into right here. But in the next request, we should delete the other role. Alright, and then we deleted the first question. Let's see if this will be enough. The context length is currently 735, so it won't be enough. We will try to iterate once again. Alright, and this time we will remove the second assistant entry right here. You can check it here on the left. It should be deleted. Alright, and now it is deleted, so the context length now is 377, which is less than our limit. Alright, I will resume this, and then we are getting our response, but now with a much smaller context. So we saw in this lecture a way in which we can keep a lower context for our messages queue for OpenAI.